Hello and welcome. My name's Chad Jeffries and I'm your host of Trilogy Tech Talks. Really appreciate you taking the time out of your day to join this discussion of Bridge to Cloud. So for those of you that don't know me, my name's Chad Jeffries, lead recruiter, marketing, branding, social media, basically just wear a bunch of different hats for Trilogy. And if you're new and joining us for the first time, we've created these tech talks as a way to bring the community together of technologists and really make it like an interactive discussion. So taking deep dives into technology products and practices and these different concepts to better learn and understand our industry. And also ultimately better serve our clients and customers. So really just helping the community in general, but this is very much an open discussion. So please don't hold back your questions. Feel free to utilize the chat function to send your questions. You don't have to wait. We will open it up for some Q&A. Throughout throughout this talk, but if you have something pressing, please go ahead and put it in the chat, and I'll make sure to get it over to discuss. So again, we want this to be an open discussion. Please, by all means, interact. So we also welcome the Trilogy Confluent series hashtag on Twitter, where I'll be monitoring comments on there too. So if you wanna go on there, you can find us at Trilogy Innov, Innov, if I can spell. So anyway. With that being said, I want to introduce our guest at Confluent for this topic of Bridge to Cloud. So our friends, Andrew Jacobs is joining us, solutions engineer at Confluent, 20 years of experience on data integration, expertise in databases and cloud computing. He's joining us from Northern Virginia. Thanks so much for joining us.
Thank you very much. Glad to be here.
Awesome. All right. So before I hand it off to Andrew, I want to preface this tech talk and why we're doing this. So as most of you know, Trilogy, we're a systems and software engineering company. For those of you that don't know, and our technologists provide innovative IT solutions to both public and private sectors. So. Now, Confluent helps its customers harness their data in motion for private infrastructures on their platform, as well as providing fully managed services for their customers' existing cloud environments. So anyway, Trilogy and Confluent have a mutually kind of beneficial partnership that's rewarded us the opportunities for both companies to provide efficient and effective solutions for government customers. That's really what we're going to be focusing on for this Bridge to Cloud is government IT systems, but really decided that we wanted to bring this knowledge to the public as a way to not only showcase technical expertise, but it's also a way for any other technologists that are utilizing hybrid cloud solutions and some different cloud environments for government customers. We're hoping you get some value out of this. So while this is our first tech talk with Confluent, we've already teed up the next 2 events in the series, and we're hopefully going to have a lot more. So all right, that's enough of me. Without further ado, I'll go ahead and pass it off to Andrew here. So I'll go ahead and make sure all this is working here. Andrew, I'll let you tell everybody about yourself too. I don't want to just pigeonhole you to my brief intro. So.
Sure. Yeah, no problem at all. First of all, can you see my screen? Is that being transmitted?
Yeah, it looks like it is. If anybody is having trouble seeing it, just pop it into the chat. But I think you should be good, Andrew.
Perfect. All right. So. Thank you, Chad, for the introduction, and really grateful to be here with you today to talk about a bridge to cloud, which should be a fun concept, especially considering how much interest there is in moving to the cloud in general across all sorts of different agencies, at least that I speak with. So I've been with Confluent for over a year. Before that, worked with database and other types of companies to really help them figure out what's the best way to get that value out of their data. And so we're going to talk about some of the challenges that historically have impeded people being able to take advantage of data that they already have, and how that relates to the cloud, and how agencies can make better use of the cloud as they're seeking to move their data and some of their services and applications into that arena.
Excellent.
And so, as Chad mentioned, if you have questions, feel free to interrupt. I think I have an agenda slide here. So, we're going to talk a little bit about some of the historical challenges that have been going on. We're going to talk about why the cloud in general. Hopefully, this is fairly obvious to most people. I will say it wasn't obvious to me when the cloud became popular. It was a question I had of what value it provided. So we'll talk about that, and hopefully we're all in agreement. And then let's talk about how are we actually going to get into the cloud? What's the best way? What's a wise approach to do that? And how can Confluent and Kafka help? So hopefully everyone on the call has heard of Kafka. If not, I will give a brief introduction into what Kafka and Confluent are. If you want to talk more about it offline, of course, I'd be more than happy to. And then we can dig into some questions.
All right, excellent.
So with that, I do want to plug that this is a part of a three-part series. So this bridge to cloud discussion happens today. In a couple of weeks, we are going to have another one where we're going to dig deeper into a part of this technology stack that we're going to discuss today called Kafka Connect. Kafka Connect is one of my favorite things. Definitely recommend you do that. It's the solution that provides a no or low code way to be able to interact and bring different systems together. And then for the end of June, we're going to have another tech talk on KSQLDB, which is a SQL layer that runs on top of Kafka. So it lets you really do amazing things with your data. So put these in your calendar. Highly recommend that you attend these if you're able to.
Yep, and I don't mean to interrupt, but just to piggyback off of that, it is in the meetup group already. Those two events, the two follow-up events. So yeah, this is more or less a 100 level class, I guess you could say, and then we'll get into the deeper dives. So anyway, I'll pass it back over.
Absolutely. All right, so let's start with the most generic, the 100 level question: why cloud? So what is the advantage in going to the cloud? Anyway, and specifically, why do I need a bridge, right? So when agencies look at going to the cloud, I've seen over the last 18 months or so just a dramatic acceleration in agencies who are ready to start adopting the cloud. For many years it was, yeah, we'll get there eventually, but for whatever reason, there's been a really heightened interest in moving solutions to the cloud. And so as you're looking at that and saying, well, we want to be a part of that, one of the things that is worth looking into is what's kind of that end goal, right? Is the end goal to take all of your applications, all of your databases, all of your different services, and kind of perform a lift and shift and just move everything to the cloud? And as you look at kind of your requirements and the different constraints that you have, how feasible is it to actually move some of these things into the cloud, right? Are there data security issues that would have to be addressed or other things? And what we frequently see, and kind of the inspiration for this talk, is even if the end goal is, yes, we do want everything running in the cloud, the process to do that really is a process. It is not a one-time event where you press a button and say, well, our old database over here that's been running on-prem for the last 10 years, we just want to move it and we want to take advantage of all that amazing cloud compute power. And so we're going to do that, move it over, and everything's done. That almost never happens that way, right? We wish it were that simple, but for a lot of applications, number one, like they may not ever be able to move to the cloud, at least for the foreseeable future. And so there's going to be this state where things almost get more complicated before they get simplified, because now instead of just having your on-prem data centers, you're introducing the cloud. And so how do you have these two different paradigms interact with one another? And that's really where this bridge to the cloud comes in, right? How can we make that process easier to take what you're accustomed to with your on-prem data centers and your on-prem development, but be able to free and accelerate and modernize those things in a smart way by taking advantage of the cloud resources. So let's talk about this and just make sure we're all level set. What do you get when you go to the cloud? And I think you probably have answers for yourself. These are some of the things that we look at. Is number one, you don't have to worry about a data center anymore, right? You don't have to worry about the physical location, the building, making sure you've got sufficient cooling, making sure you've got it manned at all times, like all of those really direct costs to owning and managing a data center become dramatically simplified. And as a result of someone else taking on that burden, it's far easier to achieve multi-zone resiliency. So that as you're deploying these applications, you don't have to worry as much about how you're going to ensure that they're always up, right? And these cloud vendors do a good job of providing a lot of tools that make it easier to get to market faster, right? Whatever your solution is, whatever requirements you're trying to deliver for your mission, there are tools that can make that easier when you're doing that within the cloud. And so with that comes that flexibility, right? So you have access to a whole bunch of different things that you can use, and typically things that are cloud in the cloud, and specifically solutions that are cloud native, have a couple of properties that are really desirable for modern development shops, right? Like extreme scalability. So one of those really tough questions when you're at the beginning of a new program or project is, okay, like how do we need to size this now? Like what is the overall use of this going to be? And that's really hard to answer in advance, right? In the cloud, it's less of a concern, because if you choose the right technology stack, you can scale that up, you can scale that down, and you can really hone your infrastructure costs with that. So that elasticity of being able to grow and shrink based on the business is really important, because at the end of the day, you're paying for your consumption. And so, I work with some agencies who really want to dig into this. So they will like schedule things and say, listen, like by 7 p.m., no one else should be working on our dev instances or QA, so we shut those down. And then at 7 a.m. the next morning, like we're going to turn them back on. And they don't pay for them overnight, right? Yeah, you'll have some residual storage costs if they want to keep their storage, but the compute and some other things, like there are some, if you do this correctly, there can be some advantages from the flexibility that you get from the pricing. And one final thing, and you guys can add your own items to this list, is you can really access best of breed solutions within these cloud environments, right? We'll talk a little bit about some of the things to be aware of as you're building a solution and not wanting to pigeonhole yourself in so that your application is completely dependent on proprietary services that would make it really difficult if, say, your agency is all in with AWS, but like tomorrow gets a far better deal from Azure, and so like starts wanting to move compute over there. So we'll talk a little bit about how you can support multi-cloud as well as just the bridge to cloud, the bridge from on-prem to cloud. So those are some of the benefits that you can expect to get when you move to a cloud. And I think you see this reflected if you look at where the money actually goes. So this is a report from Gartner, and you can see it was from January 2020, from before the pandemic. So we can all be certain that the 2021 numbers are probably much better than this because of the shift that companies and agencies were forced to undertake to move to the cloud more. And so you can see there's dramatic acceleration, especially if you look at SaaS. So you can see it's kind of broken down by different types of things, and there are gray areas between these, right? The SaaS, the IaaS, PaaS, BPaaS, and others. But SaaS obviously is growing by leaps and bounds, and I think that's a reflection of people realizing that instead of paying money to take a solution, even if it's like some open source product, and paying a vendor to install and manage that there's a lot of value in letting other people do that for you. So that's something that we as a company are very cognizant of, and that's why we have developed a managed solution. But we realize everyone's not there. There are many agencies who, as they're looking at FedRAMP, need to be FedRAMP high, right? And a lot of solutions aren't there yet. So we're on our FedRAMP journey. But for those who need that, a lot of our customers will install our software in their own cloud so that they can still achieve some of these benefits that we talked about. So hopefully we're all in agreement, and I made the case, listen, there's a lot of goodness in the cloud. So why don't we just take everything and put it in there, even if it's going to be challenging. In this reality check is, yeah, that's where we want to go, that's what we want to do, but there are a bunch of things that you really have to assess to ensure that you're ready to start moving some of these solutions to the cloud, and that you look at them holistically so that you can ensure that you're really delivering that mission value that's so critical. And one of the key components of this is the ability to start to put data in motion, right? This is a concept that's very near and dear to our hearts, because data in motion is something that we've really founded our company around, and it's something that we see across the board that government missions need to be able to react in real time to what's happening around them. Like, the world changes every minute, every hour, every day, and the days of getting your updates in batch even once a day aren't good enough. People are looking at delivering better services to citizens, to customers, to other agencies, and so being able to set that data in motion is critical. So one of my partners here in Confluent loves to talk about how there's this concept of the data lake, right? Where, all right, let's just take all of our data, let's put it in one place, and anyone who needs it, they can just go to there. And what we found, if you look back at the big Hadoop craze that had a very similar thing, is that data lake, it becomes far too easy for that to become a data swamp, right? Where there's just all of this data in there that's tough to access. You don't really know what it is. It's not well governed. And something that really resonates with us and a lot of our customers is the concept not of a lake, but a river, right? Because data is always moving, and you can have large rivers that can open up to smaller tributaries and feed other things, and that's really how we see data being used, right? Someone is producing that data, other people need to take advantage of it, and they may do something with it, and they may send it on down the line, but all of that's happening in real time, right? So this data in motion, this continuously learning, seeing what's happening, and being able to react in real time is key. And something that's antithetical to that is something we're all familiar with, which is databases. So if you just think, how does a database work? It stores information, right? So something happens, it goes into a database, and it sits there until someone decides to say, hey, I want to find out something, and so I'm going to query that database, right? And so that's a pattern that's well established, we know well. It's very important, but when you're looking for that real-time thing, especially as you're wanting to move to the cloud and things happen on-prem and you need to reflect them in real time to the cloud, what's the architectural pattern that can unlock that for you? So if you look kind of outside the government, if you look at companies that we all know, they're using the same paradigm, right? Think of Netflix without its ability to be able to analyze in real time what people are doing, so that they can make recommendations or other things. So there are a whole bunch of examples, and this is critical for the government as well, right? Because government missions absolutely can be benefited by harnessing the data that's in motion, just like these companies. One of the challenges, though, is if you look at kind of any technology stack, it looks something like this. I don't care if it's a private company, I don't care if it's government. By and large, there are a whole bunch of different solutions. Those solutions are mission critical for their purpose, and so they'll have very important data, and that data needs to be shared. And so how do you share data? Well, you got this application that speaks to this database, that talks to the SaaS service, and they all need to share it. And so you'll see a lot of point-to-point connections, right, that start to do this. So sharing data is not new. We know how to do it. It's just that it looks like this and it ends up being really hard, and it becomes much harder when you add in that third component on the right there, the public cloud, right, or private cloud, the government cloud. So when you start adding that into the mix, all you're doing really is exacerbating this problem, because the tendency is to take this pattern that people know of point-to-point connections, and they continue to use it. So they'll create point-to-point connections between their on-prem data sources and the cloud. And CTOs and CIOs and CISOs have a really hard time even understanding how many of these connections exist. Maybe that one database is being replicated 10 times to 10 different solutions in the cloud. And so you're using 10x the bandwidth that you need to, as an example, right? So there are real world implications for this from a cost perspective, as I just mentioned, by having those 10 extra connections that are going to the cloud, or the 9 extra ones, because you need to have the one. But there are others as well, like from the ability to react, to change. It's dramatically hindered when you have all of these brittle, complex interconnections. And why? Well, the tendency is, if it's really complicated and it works, don't break it, right? Because anytime you want to try to start introducing something new, you run the risk of affecting something else. So that's why new applications will be created to say, listen, we're not going to touch that. We're just going to start something new. And it just kind of perpetuates that cycle of that brittle point-to-point architecture. And so as we look at how the best way to get to the cloud and the best way to really share information, it's in real time. So something happens, whether someone fills out an application, someone is crossing a border, someone is having any sort of interaction, being able to expose in real time what that is and make data-driven decisions about it is key. And that really is what Kafka and Confluent are about. So we'll talk a little bit more about them. But that's just kind of the background on the importance of putting that data into motion and overcoming some of the historical challenges first, and recognizing them before we begin our journey to get into the cloud. And so that's what we want to talk about next. So understanding where we've been, understanding the desire to get to the cloud, how do we actually do that? And so there are some things that need to be considered, right? So when you're moving to the cloud, one thing that probably hasn't been top of mind is networking, right? So if you're accustomed to everything being in your data center, people have figured out, okay, within the data center, typically you're in that trusted enclave, unless you're doing some sort of zero trust security model, which is highly recommended, given everything that's been happening in the world. But inside of that trusted enclave, you don't have to worry as much about how am I going to connect my service A on-prem to service B that's on-prem. That's usually a solved problem, right? But if you have service A on-prem and service B that's sitting in a cloud somewhere, like what's the right way to connect to it? And what do I have to do with my clients, right? Are my clients going to remain on-prem? And so I'm moving all of the data in the cloud, and so everyone's going to be pulling everything back, or can my clients move to the cloud as well? Because one of those core tenets is typically you want to keep the data and the clients as close together as you possibly can, right? Another question, what's your CISO or your InfoSec team got to say about this, right? Are they okay moving to the cloud? What sort of controls are going to be required? Are you going to have to integrate with your on-prem LDAP? Or are you going to be allowed to set up a different one? How are you going to control who's accessing that? And if you're not careful, I mean, the cloud's got a lot of power, but if you configure your S3 bucket to have global access, there are ways that you can do this right, and there are ways that you can do this wrong. I will say, with the correct attention paid to this, things running in the cloud can be as secure as things running on-prem, but it has to be planned and it has to be executed correctly. So another question, how do you determine, how do we even start, right? What's the best way to take an application and get it into the cloud? Can I migrate something directly where we go through kind of a short-term process of moving all of the data from on-prem into the cloud, decommissioning on-prem, and then moving all of our clients to the cloud? Or are we going to have this sustainable long-term arrangement where I have to support cloud and on-prem clients together? How do I migrate that data? And importantly, how do I keep that in sync, right? There are changes that happen inside of databases. How do I make sure that those changes are reflected in real time so I don't have to do like a batch update and I've got information in the cloud that's 24 hours old? So these are some of the things that you have to think about as you're plotting out your journey into the cloud.
Hey,
yeah.
Andrew, I don't mean to interrupt you here, but we have a question from Josh Ayers joining us. Thanks, Josh, for asking this. But so he said, so Confluent provides more of an organizational tool for cloud computing.
Yeah, great question. So we'll get into Confluent a little bit. Confluent provides a platform that can dramatically accelerate and simplify data sharing between on-prem, cloud, or multiple cloud providers. So at the end of the day, Confluent and Kafka they're a distributed log. And so if you're not familiar with them, it's a very simple architectural pattern to kind of put in your brain, because we're all familiar with logs, right? Logs are ways of storing information where any new piece of information that comes in just gets appended at the end, right? So the way information gets persisted within Confluent is the same. And so Confluent has a bunch of things built into it that we'll talk about that allow it to take information from a variety of different sources and to be able to share it with a variety of different sources and to be able to replicate it between different places with ease. So that operational burden of how do I get my data out of this specific database, or how do I get my database into this specific application? How do I ensure that my data from on-prem is reliably transmitted, even in the face of outages and other things, into a cloud or to multiple clouds, and vice versa? How do I ensure that data that's generated in the cloud can be made available back to on-prem clients? So like we have nothing to do with the network layer or anything else. We solely focus on the data, and we provide a solution that when you plug us in, makes it look as though all of your data is local to you. So you can locally produce and you can locally consume all of that information, even though that data may be produced by someone in a different cloud than you. So we'll talk about how that replication works.
So that was actually, we have another follow-up question from Steve. Thanks, Steve. Is it possible to determine which data is replicated, or does it need to be the whole thing?
Yeah,
itself?
Great question. We want to provide the ability for end users to be able to decide which data gets replicated, and so we have a whole bunch of different ways of doing this. If you want to dig into it, and if you got specific use cases in mind, I'm happy to speak with you afterwards. But yeah, you've got complete flexibility about how you want that data replicated. And so we have ways that we can create clusters that actually can span the globe as a single logical cluster, where you have the ability to determine which pieces of information are going to be shared to different locations. And you get to determine which of those are going to be synchronous replications, meaning that everything is going to have it at the exact same time, or asynchronous, meaning you'll have some sort of a primary and someone else will get a copy of it in near real time, but not completely real time. So we've got amazing technology built in to solve that challenge and give you the flexibility to say, I want to share all of this, I want to share none of this, I want to share a modified version of this, and so on and so forth. So hopefully that answers the question, Steve.
Excellent.
Great questions. Keep them coming. Anything else?
Yeah, for sure. Nothing else has come up as of yet. So
great. So we talked about networking in general, I mean, networking, if you haven't been exposed to cloud networking, it can be pretty overwhelming because there are many different ways that you can connect things up. Cloud service providers have done a great job of creating segregated ways, multiple virtual private clouds, so that you can segregate your information apart from everyone else's. But as you do that, you have to figure out, okay, when I do want to provide access, where's that access coming from? What's the right way to do that? And so that's one thing to think about. Security is another one, right? Is this like public data no one really cares? Do I need to encrypt it? Do I need to tokenize it? Do I need to, have this work with my single sign-on solution? All of these sorts of questions have to be figured out, right? Because as you're introducing a completely new data center, essentially, and figuring out how you're going to solve the security issues across those links, and maybe those links are public internet links, right? Security is going to be critical, and so having the involvement of the CISO and their sign-off and their instruction is really, really important. Another one, how do you determine which application is going to go first, right? Where do we start? And this is frequently going to be driven by budget, and probably even more frequently going to be driven by need. So I'm working with an agency who, it has an extremely large on-prem presence. They want to get to the cloud. They've been struggling to know where to start, and then a new regulation was introduced that dramatically expanded the type of reporting and computing that they would have to do from a regulatory perspective. And they looked at their on-prem capabilities and realized, listen, in order to fulfill this, we'd have to spend a bunch of money to stand up new hardware, right? And we all know how that story goes, like the process of contacting Dell, getting the server, waiting for it to be provisioned, and how long that takes. And they didn't have that time. And so the cloud provided them a great opportunity to be able to meet this requirement with far less effort and energy than would have been required had they done it on-prem. And so that was kind of a natural selection that was made for them because the trade-off was so stark. But frequently the trade-offs and the insight into how to do this is not as clear. And then figuring out how you actually do this, I think this is probably one of the most challenging things, right? Are you going to set up a point-to-point connection between them? How do you ensure, if you're doing that you're keeping everything in sync, right? If you're going to do a cutoff, how do you schedule that? Who's going to be responsible for all this as well, right? Are you going to be, like, is there a dedicated team within your agency that's going to handle all of this? Are there standards that you have to adhere to? And so what you don't want to do is end up with something like this, right? Where you have all these different data centers, some are on-prem, some are in the cloud, and you have a bunch of different solutions. And this is really like that spaghetti diagram that we shared previously, where, yeah, you're in the cloud now, but you've got all of these really brittle links that make it hard from a higher level to understand what's happening. And so Kafka and Confluent provide a much simpler mental model to reason about this. And that bridge to cloud really can be Confluent. And so I think we're going to dig into that, which is, how can Confluent help with this? And if it's okay, I'm going to grab a whiteboard. Let me bring this over.
Yep, you're still good, so.
Can you guys see the whiteboard?
Looks like it on my end, so should be good.
Okay. All right, so let's start off with a simple example. All right, so let's say you've got an application, and that application talks to a database, right? So that's all on-prem. This is normal, and you decide, you know what? We really need to take that to the cloud. So how are we going to do that? Let's say we got some fancy schmancy database out here in the cloud, and that's where we want it to go. So, I mean, there are a lot of solutions out there, right? That'll just say, hey, stand up our service, whatever. You tell us where the source is, you tell us where the destination is, and we'll take care of that, right? But we know if you go down this route, it'll work. But thinking longer term, there's a better way. And the better way is if you take something like Kafka, this distributed log, you can stand that up, and Kafka, again, if you think about it and reason about it as a log, we have very easy ways to get information from databases. So we have a connect framework with over 120 different connectors, and you can say, hey, plug in this specific connector, Kafka, grab the data from the database, and Kafka will store a copy for you inside of it, and you get to choose how long you want that copy to be in there. Okay, so at this point, great. We still have our application, we still have our database, nothing's been disrupted, and now we have a copy in Kafka. So what can we do with it at that point? Kafka is an amazing decoupler, which means your sources don't have to know about their destinations, and your destinations don't know have to about their sources. All they have to know about is Kafka. And so your database with that connector, with no code, was able to take and put information within Kafka. And once it's in there, you can give it to whoever wants it, you know, provided they have proper access to it. And so you can have another app here on-prem, right? And say, hey, you know, we want that information as well. We don't want to hit that database directly, so we're just going to get it directly from Kafka. And so again, you can use a connector to do this, or we have APIs that allow you to do this, and you can get that information from Kafka to feed that application. But you can do other things as well, right? Because it's in there, you can have as many different consumers who are grabbing this information as you want. And I'm actually going to change this. So we can say, you know what, I really want to make that available in the cloud. So what we're going to do is we're going to put another version, another instance of Kafka in the cloud, and we are going to use something built into the Confluent platform called Replicator. I spoke about this earlier. We have a bunch of great different technologies that allow you to share your data. Replicator is one of them. So when you enable Replicator, you tell it, hey, I want to share these topics from this cluster to this cluster, and it does it in a fault-tolerant way, which means if your connection between those goes down, it keeps track of, hey, this is the last message that I sent, and as soon as that is restored, it just picks up right where it left off. And so everyone who's in the cloud still has their data, everyone who's on-prem still has their data, but Replicator gives you that copy of information so that it's now sitting in the cloud. And again, once it's in the cloud, what can you do with it? Well, you can use this connect framework, and this database over here can say, hey, I want a copy of that. And now you've got this complete data pipeline that will allow you to capture any changes that are happening within that database and be able to put them into your local Kafka cluster, be able to replicate that to your cloud Kafka cluster, and then anyone in the cloud can consume it locally. So what if you have another client in the cloud? What if, you know, instead of a database, or in addition to a database, you want to put it in S3 for long-term storage? No problem, right? It is just another consumer of that data. And one of the key tenets here is this database and S3, they're not contending with each other. They can be reading from different places in the log at different times from within Kafka, and they are not affecting the other's ability to be able to grab that data. So you can like put this in Elastic, for example, right? If you want to be able to search it. So you can put this information anywhere you want. And let's say there's a different data source, right? Let's say you have a mainframe, because we all love mainframes, right? So you got mainframe, how are you going to get the data there, right? Because every time you have a consumer of that data, you're paying for it on the mainframe, right? You have to pay for MIPS. So what if you just paid for them once, and you said, you know what, we're going to take all the changes and we're going to put them inside of Kafka. And so, IBM is a great partner of ours. They have a connector that works with their mainframes that will do change data capture, take all of the changes that are happening inside that mainframe, they can put it inside of Kafka. And again, once it's here, what can you do with it? Well, you can have, like, this application can read it, it'll get replicated over here, and once it's in here, anyone who wants it, who has access to, will be able to grab a copy of it as well. So you pay once to get the data out of the mainframe, and you can see that data is now freed. It's available in a decoupled way that anyone who needs it can grab it. And so let's say this is your architecture today, right? Let's say, okay, good. And then let's say tomorrow your boss comes to you and says, you know what, new initiative, new program just got funded. We need to be able to grab that mainframe data, and we're going to do some machine learning with it. And we are going to stand up a brand new service. You've already solved most of your problem, right? Because your data is already available in the cloud, so you can grab it, you can take it, and you can say, I'm going to put this to a machine learning library who's going to consume it, and that machine learning library, when it's done with it, can put the data back into Kafka. And then once it's in there, you have now a different version of that data set, right? You can have your raw data, but then you can also have this enriched version that has the results of your machine learning. And then again, anyone who wants access to that, you can send it to this database, you can send it to S3, you can send it to any client or customer you want. Again, with these 120 different connectors, it dramatically simplifies the work that you have to do. And so you may be asking yourself, okay, that's great. What about like the apps, right? Because we started and we had a couple of different applications here on the left, on-prem, right? So they're still on-prem. Well, with this, when you have migrated your data and you're using Kafka, it's grabbing all of the changes from this mainframe, from the database. We have an Oracle CDC connector as a part of this. So if you have any Oracle, we have built-in change data capture capabilities within Confluent to be able to grab all the changes and replicate them. So we can say, you know what, we're going to turn that app off and we are going to stand it up in the cloud. And again, instead of that app getting that data from Kafka on-prem, it's just going to grab it from Kafka on the cloud. And so everything stays the same with it. It's dramatically simplified, right? Where it doesn't have to worry about, well, how do I ensure that the networking is right, and how do I make sure the security is right, and how do I, all of these other questions that have to be answered. They don't. That same architectural pattern works. They just have to stand it up in a different place, point it to a new Kafka or Confluent cluster, and they get all of that data, and they can, if they wanted to, they could rewrite that app using modern technology. So microservices, whatever they want up in the cloud, but the data that's feeding it could still be, from this traditional database or from this legacy mainframe, right? But you can still harness the power of everything that's available in the cloud. So this app now, instead of being something that's heaven forbid, you're standing up on bare metal, it could be something that you're rolling out in Kubernetes in the cloud, right? And it is a part of a managed service there, or a SaaS service where it scales up and down automatically. But that data is available.
Question for you, and this is just a question from me, and sure. I'm definitely not as technical as probably most people here on the call. But what if you had multiple cloud? What if a customer had multiple cloud environments? Because we obviously see that with just the scale and the amount of data that our government clients are dealing with. So yeah.
Yeah, great question.
I hope that's relevant to what you're saying. That's just a question I had, though.
Yeah, okay. So you've got your app, you've got your database, you got your Kafka on-prem, right? So this is the same diagram we had before. So we'll put that here. So now let's say up here, you got AWS, and then over here, red, you've got Azure, right? So how do you do that? Well, one way is you can put a Kafka cluster in each one of these, and you can use that same replicator technology. Replicator to be able to share information. And Replicator can go bidirectionally, right? And so what you can do is you can stand up even links between your cloud providers once you figure out the networking. But we do have customers who have done this before. And so instead of this being a point-to-point thing, what it starts to turn into is something like a data mesh, where data can exist in a bunch of different places. So let's take an example. Let's say we have an app in AWS that sends a message to Kafka, right? As soon as it does that, that message is going to come over here, be persisted on-prem, and it'll be replicated again over in Azure. So if you have an Azure app, instead of having to pay for networking charges, let's say you've got multiple apps in here who need that, right? Instead of each of them going and grabbing it directly, which they can do, right? So they could, from Azure, target AWS. We're not going to have them do that though, because again, you want to simplify this. So for them, I did those arrows the wrong way. They're going to consume locally, right? So for them, even though that piece of data was generated in AWS, right, and went from Kafka here, came down, landed in the Azure version of Kafka, and as soon as it does that, because they're subscribed to that topic, those applications each get a copy of that data and say, oh, there was a change in this record. Chad changed his last name, and now we know, right? You do the same thing on-prem. So that data could come over here, and it can be shared with this app as well, right? So again, for each of these, they exist within their own little sphere. They don't have to worry about what's happening in another cloud. They just have to worry about what's happening with within my own cloud. And as long as data is shared and replicated, it doesn't matter if these links go up or down. Kafka is going to ensure, and Confluent is going to ensure that that data is available so that people can make use of it however they want. Does that make sense, Chad?
Yes. Yeah, thank you.
Yeah. So one of the things, sorry, another question?
Yeah, there is another question.
Okay, go ahead.
How easy, and this is from Steve, so how easy is it to scale a Kafka cluster up and back as needs dictate? And can that be automated with logic, i.e. CPU, mem utilization, and network saturation, etc.? So
yeah, that is a great question. So if you're looking, and I don't know that I explained this very well. So Kafka is an open source project, right? Confluent is a company that built a solution on top of Apache Kafka, and the people who started Confluent were the people who originally wrote Kafka. So over 80% of the committers to Kafka today are Confluent employees. And so, like, this is our life, in our, what we focus on is data streaming. If you wanted to do something like that today, Steve, in open source Apache Kafka, it's really hard. Like, you can do it, but you have to write a lot of scripts and do other things. And so we saw that as one of the key challenges. And so inside of the Confluent platform, there's something called the self-balancing cluster. And so the self-balancing cluster can do exactly that. So if you need to add additional nodes, like Confluent is a distributed system that runs on commodity hardware. So you need more, you can spin up additional EC2 instances, for example, add them to your Confluent cluster, and Confluent will automatically distribute all of that data and take care of it. And say, you know what, we want to even this workload out. We used to have 3 EC2 instances, now we have 5. And so we want all 5 of those operating at their peak capacity, as opposed to 3 of them handling 80% of the workload and these other 2 handling 20%. That doesn't make any sense. So that's kind of the scale up. Scaling back down is something that you can do as well. So you have to give it some time, but you say, hey, we need to take this workload down from 5 back to 3. And so what happens then is it says, great, so it starts moving all of that data off of the 2 nodes that are going to go down onto 3, and as soon as that process is complete, those 2 nodes can be decommissioned. So the key part of your question, I think, Steve, was, can that be automated? And a lot of it can be at this point. So there are APIs that will allow you to do that. We don't have anything built in that will automatically do it for you. It is something that we're looking at. So if you've got opinions on the right way to do that, definitely talk to us about it. But
and then they'll hire you.
key things to be able to make use of that power. And I will say, Confluent Cloud, which is our managed service, does a lot of that for you. And so we have things like tiered storage, where in the background we're making use of different tiers of storage, and that makes it far easier to be able to size your clusters up and down. And so, yeah, definitely, these are the types of things that you can do in the cloud that you also can do within Confluent. It'll take a little bit of elbow grease to like set the right metric. Like, are you going to say, when CPU hits 80% over this time period, then we want to do something? So what you don't want to do is flap back and forth, right? Where whatever your threshold is, if you're going back and forth, you're spending a lot of time, going up and increasing your scale and then bringing it back down, because there is obviously that cost involved in moving the data off and then distributing the data back over. So hopefully that answers the question.
Perfect.
Anything else?
No other questions as of now. So.
Okay. One last thing I want to talk about is that one thing that we frequently get asked is, I've got data, I got my database, and I want to put it in Kafka, and I want to share it. So we're going to replicate. I want to share it with this other database over here, but that database is totally different, and I don't want them to have all of my information, right? So this is on-prem, this is cloud. So what do you do in that scenario? Well, built in to the system is something called KSQLDB, and you guys are going to hear about this at the end of June. Did I totally did not spell that right? Did I? Yeah, I just can't write KSQL. That's supposed to be. So what KSQLDB does is it allows you to write SQL queries. So you could say, you know what? Think of it as a consumer. So when this information comes in, let's say it comes in on a raw topic. So that raw data comes into KSQLDB, and KSQLDB takes that information and it creates a different representation of it. You can think of that as like a materialized view. And as a part of that, you can redact information, you can transform it, you can make it look however you want, and you put that back in Kafka as a different topic. So then your database here would subscribe to that second topic, that curated topic. And so everything that KSQLDB did, now it gets exposed to this database, which means that raw stream is not something that that database downstream has access to. It only gets access to that curated set of data. And so we have another thing called Kafka Streams that does the same type of thing, but these are very powerful tools in your tool belt when you're looking to run a hybrid cloud environment, because frequently you do need to share that data, but you need to share it in a little bit different way, right? The schemas may be a little bit different. You may not want to give it absolutely everything. And so there are these tools that you can leverage in a very easy way to be able to create these different representations to ensure that people are getting what they want. So I think that's the whiteboard. I've got a few more slides. I know we're up on time. Do I have any other questions or?
Nothing's come through nothing's come through yet. Yeah, I know we're running up on time, but by all means, continue on. We could probably stay about 10 minutes over just to let everybody have the chance to ask any more open-ended questions. But yeah, if you want to.
Perfect. I'll take 30 seconds and just kind of, I talked a little bit about the differences between Kafka and Confluent. Something that's built into Confluent are, think of it these things. Confluent is a cloud native version of Kafka. And so it has these types of things. I talked about the self-balancing clusters. I talked about our tiered storage, which lets you offload information. We have an operator that allows you to deploy this very easily inside of a Kubernetes environment. So you can almost have your own private cloud version of this running that can scale up and down as you want. And if you're using Kubernetes, that becomes far simpler. We've got all of these things that have built-in resiliency and data sharing. And all of these capabilities are things not available in Kafka, but they are available in Confluent. So when you're working to support these types of use cases where you need information available in the cloud and on-prem and share it back and forth, Confluent is that bridge in between that lets you do that, and it can do it with an infinite amount of data as well. You can store as much as you want. So going back to that use case that I mentioned of, hey, we need to stand up a new machine learning capability. If all of that information is already stored in Confluent, it's very easy to simply, stand up that service, point it to Confluent and say, hey, I am allowed to grab this topic. So it'll start reading from the very beginning of that log, grab all of that data and put it into whatever solution that you want. So that's one of those key features that really just makes life easier, as well as these connectors. So of course we have a bunch of security stuff built in as well, being able to audit information, to see who's done what, secure information, to be able to have role-based access control, all sorts of good things. But that is that's what I wanted to cover on cloud. So any questions that you guys have, we're available. That's what we're here for. If you guys are kind of kicking the tires on something, you want to try something out, we'd love to work with you to make this technology available to you so that you can kind of see how it actually works with your data and your environment. We can talk through some of the use cases that you've got. So, we're here to help. And we realize this, moving things to the cloud isn't always the easiest thing, but we've got a lot of experience in doing it and would love to assist if we can. So,
excellent. Yeah, thank you so much, Andrew. It was certainly good information. I hope you guys got some value out of it. I definitely learned something, but no, I really appreciate you, Andrew. If anybody has questions, it doesn't even necessarily have to be related to the topic at hand. If anybody has a question for Andrew or myself, feel free to shoot it in the chat here. But let's see. Yeah. Okay. Yeah. So there's I don't think anybody else has questions here. So we'll go ahead and wrap it up. I'll just want to make a couple announcements here, obviously. So I'll be sending out an email just to kind of summarize everything that we talked about today. Andrew, is there any way that people can reach you? What are some things that you're working on or coming down the pipeline for Confluent? I don't know if there's anything that you wanted to plug.
Yeah, I mean, if you want to contact me, I'm not on social media very much. Or anything, but Confluent has an amazing Twitter account and a blog where we share what's happening. There's been a whole lot of work that's happening within this sphere of event streaming and being able to harness and put data in motion in real time and take advantage of it to make that even easier. So if you're interested in those kinds of things, I definitely recommend you go to our website. You can subscribe to those things. I think we've got, I work with a person named Dan Garber. If you want to reach out to him, he's kind of the account manager that handles all this, or you want to learn more about Confluent Platform, there's a link there that you can grab. But yeah, a lot of information out there, and we're happy to help however we can.
So I'll make sure to I'll make sure to send in the summary a link to this stuff too. And as we've been talking throughout this this conversation, obviously on the 10th, June 10th, we have what is it? Capturing continuous data streams with Kafka Connect. So that's happening on the 10th, and then KSQL streaming SQL for Apache Kafka is the June 24th tech talk. So we're going to take deeper dives. There'll be the higher level classes, I guess you could say. But I want to thank you all so much for joining us. And Andrew, again, thank you so much for your time. This was certainly helpful. I hope everybody got something out of it at least. So I appreciate your participation and questions too. So. All right. Well, hey, you have a great day, Andrew, and thanks again, everybody. And yeah, look forward to seeing you guys next time.
All right, sounds good. Thanks.
All right, thanks. Take care. I hope you enjoyed this episode. Please don't forget to like, subscribe, and share.